The diffusion models are real-time game engines. So this is Doom simulated, right? Watch the Fireship video on it. Do you have it? It's just a rendered hologram. I don't know exactly how this works. So we have this diffusion models are real-time game engines. As far as I understand how this works, the AI is creating the content as you play through the game. And so you need a very powerful GPU for this to work. And it's essentially, if you go and look to the left here, it is going to generate the world in real time. The renderer is creating the... is it actually geometry here? The geometry, and then show you the contents of that. All right, so essentially, I wonder who these people are. Google Research, and then University, Google DeepMind. So these people have worked on this, it looks like. It's by far not even close to being playable. So let's see, this is a video of it. These are real-time recordings of people playing the game Doom, simulated entirely by a neural model. Okay. Okay. I mean, it doesn't... Interesting, yeah. Why is he so slow? Oh, wow, yeah, okay, so the FPS is very low, isn't it? And so this is generated on the fly. How does it know where to put, like, a... How does it know where to put a corridor, and how does it know where to put a door? And also, what are these black dots? You saw that? Here, take a look. When he went close to the door, yeah, you see these black dots all the time? There's some artifacts going on. Okay. It uses gameplay footage. So essentially it recreates the level based on the gameplay footage and then generates the geometry in real time. But why would it not just generate the geometry once and then create an executable? I don't understand that, because it ultimately makes this less efficient, because it has to keep generating it all the time. There is no geometry. It's all images. So it generates the images in real time. Does it actually? It's just frames. Okay, so it's just generating frames. Okay. Okay, I see. Yeah, you can see that. Yeah, you see these black distortions here? It looks like it's dying or some... You know, this is the black soul of the AI coming towards us, you know? We can already see the beginnings of the AI becoming to, you know... what is it called? Becoming self-aware and showing us that, you know, just wait, you know, just wait. A couple of years down the line, it is our turn. Guys, we have to be careful. Interesting, cool. All right. Real-time recordings of people playing the Doom simulated entirely by the GameNGen neural model abstract. We present GameNGen, the first game engine powered entirely by a neural model that enables real-time interaction with a complex environment over long trajectories at high quality. I mean, yeah, but it's just images. It's not even like a real game, right? GameNGen can interactively simulate the classic game Doom over 20 frames per second on a single TPU. Guys, what is a TPU? Tensor processing unit. So what is that in my computer? Probably like a 10 times GPU. Toilet paper unity. Tiny unit. So it is essentially a 10x GPU. So that means... if I wanted to play this game right now, I can't, because I need a TPU. Otherwise, I have like 1 frame per second, if anything. Cool, so in the future, to generate games with the visual fidelity of PlayStation 3 games, we might need to have our own country worth of energy. Yes, yes. Essentially like that, yeah. TPU is probably the cloud, right? In the cloud, right? If you have an RTX, you should have TPUs. I don't know, man. I don't know what a GPU is. I'm not a tech person. So I would just say that my game, or this game would run for me in 2 FPS. Okay. The next frame prediction achieves a PSNR of 29.4, comparable to lossy JPEG compression. Human raters, whatever that means, are only slightly better than random chance at distinguishing short clips of the game from clips of the simulation. Yeah. I mean, if we take a look deeply into the recordings, we can see that it distorts sometimes, which is, maybe this is part of Doom, but I've never seen that. And it's obviously very slow. So you would have to speed it up to make it comparable to a real Doom game, right? 20 FPS is very, very slow. And obviously you can tell the difference. GameNGen is trained in 2 phases. One, an RL agent learns to play the game and then training sessions are recorded. And 2, a diffusion model is trained to produce the next frame, conditioned on the sequence of past frames and actions. Aha, so let's say someone played Doom and he got to a corner and then he turned left. And for you guys that would be right. And then the recording shows that it's been saved by the model, shows what the game looks like after turning left, and then it will, and it's also recording the different frames that has been shown, and then it takes these, essentially, well, now it's taking a little bit of the mystery away, because it's literally just storing these images now, and then displaying, let's say, a lerp between the 2 images, let's say, in real time. So it's just lerping between 2 images, essentially. It's like a video. Yeah, kind of like this. So essentially, like, that's what I get from this, right? Maybe it's doing more. Conditioned on the sequence of past frames and actions. Conditioning augmentations enable stable auto-regressive generation over long trajectories. So I wonder if you can apply this to 3D games where you have real geometry in the future, and then it just records these 3D games, but you still need a game to record from, essentially. It's not creating a new game. It is just rebuilding an existing game. Doom is a 3D game? Yeah, I thought so, right? So let's say we play Witcher 3. Then we would record the game, and then it would just give us the images pre-recorded and then lerp between the 2 images, maybe transform them in a way that it creates a new image, because in the recordings we didn't go everywhere because Witcher 3 is a huge world. But it still needs to, like, the fact that I can't get over is that it essentially computes images. And that seems to be a lot of processing power. And you need a game to exist. And so I guess what we could do in the future is then take these images, create new images, new worlds. But we would still always have the feel of a game in the new game that we make. Let's say we distort the images, create a new world, and then the resulting game looks way different, but it would still feel the same because it's literally Witcher 3, right? The mechanics of Witcher 3, that doesn't change. Unless you try in the future to merge 2 games together and then pick some here, some here. But then maybe that's, again, very simple because it doesn't make any decisions on which feature to pick over the other. This one doesn't use prompts. You will use placeholders in 3D and just do the mechanics and then use a prompt for the style. It's a thought experiment, not a viable product. Yeah, I guess it is. So, but we're poking holes in this full gameplay video. Yeah, we're gonna watch that in a second. And then, let's see, the data collection via agent play. So let's say an agent, I don't know what action means in the game environment. I guess does an action in the game environment, and then so RL training, how does that happen? Observations and rewards. So like it stores these images, stores episodes during training. Action embedding. And what that means. Previous action, current action. Okay. Previous frames. So these are the actual frames. Essentially a big model training thing. Okay. Where it stores the frames and does something with the frames. And then, yeah. Data collection via agent play. Since we cannot collect human gameplay at scale, yeah, because we don't have that many humans, right? At first stage, we train an automatic RL agent to play the game. Yeah, so because then they can play the game indefinitely, essentially. Persisting its training episodes of actions and observations, which become the training data for our generative model. So first they have to make the AI play the game, and then once the AI is able to play properly, then they collect data. Training the generated diffusion model. But I've learned about this as well, that AI will always find a certain way to play the game, and therefore there will be essentially parts left out because the AI makes decisions based on previous decisions and rewards. So I don't know, like how thorough this is. Training the generated diffusion model, we repurpose a small diffusion model, stable diffusion, and condition it on a sequence of previous actions and observations, frames, to mitigate autoregressive drift during inference. inference. You guys understand this? Okay, yeah. So we corrupt context frames by adding Gaussian noise to encoded frames during training. This is probably the black stuff that we see here. This allows the network to correct information sampled in previous frames. And we found it to be critical for preserving visual stability over long time periods. Have a look at the longer videos, it's crabs and full of bigs. Yeah, we have seen this. Latent decoder fine-tuning. True. The pre-trained autoencoder of stable diffusion. Yeah, which compresses 8x8 pixel patches into 4 latent channels, results in meaningful artifacts when predicting the game frames, which affect small details and particularly the bottom bar HUD. To alleviate the pre-trained knowledge while improving the image quality, we train just the decoder for the latent autoencoder using MSE loss corrupt computed against the target frame pixels. Okay, why don't you shake your stable diffusion for us? Crystal clear. Bib text. And then acknowledgements. We'd like to extend our huge thanks to... Thank you. And so this video is essentially explaining it. I wonder how he explains it now that we have kind of figured out how it works.
Google and Tel Aviv University published a paper that put game devs and AI doomers on life support. What you're looking at right now is not gameplay from John Carmack's 1993 classic first-person shooter, Doom. It's actually a brand new game from 2024 powered by GameNGen, the world's first entirely neural network-based game engine. The environment, the collisions, and the graphics are all simulated.
Now I understand what they mean by neural network.
And the graphics are all simulated in real time. Network-based.
Now I understand what they mean by neural network. This is essentially what it creates. Yeah, it makes sense, right? There's all of these paths, and then there's more paths, and it just goes on and on and on.
Game engine. The environment, the collisions, and the graphics are all simulated in real time at 20 frames per second, and not a single line of code was written to develop this level. Back in March, Jensen Huang predicted that most video game graphics could be generated by AI in real time within 5 to 10 years. If he's
no, he's wrong. No, I don't think so. No, I don't think so at all. And seeing how this works at the moment, we need a working game for this to happen, which we do, but then it's the same game. This is just hype for money. I think so too, yeah. He keeps trying to push his crappy AI. Reminds me of something, yeah. Do this, this is wish list for shareholders. Yeah, I guess this is just for shareholders because like if we take a look at this like we just did, this is just so far away from what actually can happen. No.
right, when GTA 7 comes out in 2042, just imagine being able to run over billions of unique NPCs across multiple parallel universes.
These are just images, and it trains on existing data. The issue is that it needs to generate something new and interesting. This is the problem. Not something that already exists, that is repeated. Because that's what AAA does. We already have this. This is AAA, man. Oh my god, I just noticed. They found a way to automate AAA, guys. They take Call of Duty, train AI on this, and they no longer have to make a new Call of Duty game because AI will do it for them. Smart. Actually, this is gonna be the future of AAA. 100%. Call of Duty.
Was ist AAA?
AAA heißt, nein, das ist die Qualität von dem Spiel. AAA ist sehr... Guys, what's the name of AAA? What is the abbreviation for AAA?
Weil ich so oft gehört habe.
What is the abbreviation? Massive? AAA. Sorry, it's AAA now. It's not an abbreviation. So, A steht für gut und 3 A's sind halt dreimal mega gut. Ne?
Ach so.
Also einmal gut, zweimal gut, dreimal gut, ne? 4-mal gut. Hm?
Okay.
Das ist wie so eine Rating, ja. Wie eine Note in der Schule. A ist die beste Note. Hm? Ja. True. You can say it's the blockbuster games, yeah. Yeah, it's like, yeah, exactly. The power of anus to the 3rd degree, yeah. Okay. Yeah, guys, AAA now. Cool, yeah.
In today's video, we'll find out how this black magic actually works and whether or not it's the future of game development.
I don't
It
think
is
so.
August 29th, 2024, and you're watching the Code Report. Before we can
morning.
understand how GameNGen works, we must first understand Doom, a game that was revolutionary when it came out in 1993. Not only was it a violent game that moms hated, but it was a huge technical achievement in 3D gameplay. While the player runs around obliterating demons from a 3D perspective, the enemies
2D,
and objects
isn't
are actually just 2D sprites rendered at fixed angles.
See, guys, I told you. I mean, rendered at fixed angles, so it is kind of 3D, yeah.
This differs from modern games that use billions of triangles and linear algebra to render 3D objects. The key takeaway here, though, is that Doom is not a true 3D game, and its underlying technique is often called 2.5D graphics or billboarding. In other words, you take a bunch of 2D images, but skew and scale them in ways that make it look like a 3D environment. It's genius, so let's take a moment of respect for its lead developer and legendary programmer, John Carmack. Not only did he create Doom and Wolfenstein and Quake, but he open sourced the Doom engine in 1997, which inspired an entire generation of new programmers. Currently, he's working on artificial general intelligence at Keen Technologies, and
So, like, the last thing I heard of him was he was working on AI, not AI, he was working on VR stuff. And maybe he stopped working on that and now he's working on something else. But I feel like AI will just, even if he works on it, he's crazy smart, it will still take more time.
let's hope he gets there before Sam Altman does. But now that you understand how Doom is just a bunch of 2D sprites, GameNGen becomes a little less magical, which is based on Stable Diffusion. It relies on an augmented version of Stable Diffusion 1.4, which is trained to predict the next frame based on the sequence of past frames and actions. And the other big component of the architecture is a...
Is it just using the past frames? Is it not taking already known next frames into account as well? So like here's the next frame that it uses, right? If it's only using previous frames, how does it know the next frame then? Because it should take a look at the possible next frames too, right?
reinforcement learning agent, which is trained to play the game and record itself like an artificial Twitch streamer. Google has taken a lot of L's recently, but it's also been shipping some amazing tech, especially when it combines reinforcement learning with generative AI. Like AlphaCoder uses a similar technique to beat virtually all competitive programmers, and AlphaProof can beat almost...
This is so bad. Like, listen, this is so, like, these are predefined solutions for predefined problems. Like, this is not gonna happen in the real world, man. You can learn this all you want. The possibility of getting that exact issue are so minusculely low. Like, yeah, it helps you think and solve problems, but it doesn't help you in the real world. Because you're gonna have so many different problems. Like, this AI falls flat on solving any problem that you come across when, let's say, making a game. Like, this is great for predefined problems that have been there for ages. Using namespace std. That's bad. Yeah, true. Good catch there. What's up?
Coder uses a similar technique to beat virtually all competitive programmers, and AlphaProof can beat almost all math Olympiads. But when it comes to the GameNGen, their biggest challenge was addressing autoregressive drift, where the quality of gameplay starts to decrease over longer sequences. The model only has a limited context window of about 3 seconds or 60 frames, but in a fast-paced game like Doom, that's all you need for real-time gameplay. And despite the small context, it does keep track of health and ammo based on the actions taken by the player. The big question, though, is does this make game developers obsolete? The answer, of course, is no. This game is barely playable, and the tech has no practical application for the time being. But in the not-so-distant future, you could imagine a developer like Rockstar Games using an RL agent.
No. We get Call of Duty. We take the previous Call of Duties, train the model on them, and then it will just generate a picture generating Call of Duty game for the next 5 years. Because it's literally just the same formula all the time. Okay, so no one's gonna notice a difference. As long as it runs reasonably fast, so that I'm pretty sure they will be able to fix this in the next couple of years, right? That's what I think they will be able to fix. And then we just have a bunch of Call of Duties coming out. And they could have like a Call of Duty coming out every month if they want to, essentially. And then all of the Call of Duty engineers, they don't need to exist anymore. Gone. I wonder, like, I'm pretty sure this would even sell. Yeah.
To play the GTA world, combined with some futuristic generative 3D model that can spit out new terrain, NPCs, and even storylines on the fly. But you really shouldn't be playing video games because women find it the most unattractive hobby for men. Real world.
There's no way. There's no way this is real. I've come to, like, there's no way collecting figures. This is more unattractive than playing video games. I've met many, okay? I've had many dates, and this was not the most unattractive thing, okay? They're wrong. Real. No, it's actually real. Real gambling addicts over gaming. Sure, yeah. Crippling gambling addicts over game. Like, I wonder where this comes from. Like, this is so bad. Like, when was this even taken? Like 1990, when video games just came out? Like this right here, by the way, is like so far down. This is starting to get cool now because everyone is gaming. It's the biggest industry in the world, the biggest entertainment industry. It's so wrong. Phone games. Huh?
Playing video games because
Online
women
trolling.
find it the most unattractive hobby for men. The real world-changing
Wrong.
application of technology like this is going to come in robotics. Real-time environment simulation will allow robots to train rapidly without physical hardware. Like when it comes to capital punishment, it's extremely hard to gather enough data for a large model. Well, not anymore thanks to Google's Project Talent.
The new device is designed to be as humane as possible, emitting soothing white noise and putting prisoners on a cushioned seat.
Oh my god. We are dying, guys. We are creating killing machines right now. Am I watching this for real right now? Is this actually happening? I think this is a joke. Is this a joke? It's a joke? It's a fake video?
Before its metallic talons dig into their necks and painlessly wrench their heads off.
Okay.
The Figure 2 robot was just released a few weeks ago. Elon is building Optimus robots. NVIDIA recently unveiled Project Groot. Google's investing heavily in robotics research, and they're all trying to make Terminator-like
Oh, stop trying to make Terminator happen. It's not going to happen.
humanoid robots a thing. And if they succeed, we'll have to put yet another dollar in the Arthur C. Clarke was right jar.
The future does belong to the robots. Biological
probably.
evolution has about come to its end. They will start to think, and eventually they will completely outthink their makers. Is this depressing?
Yep, this has been the Code Report. Thanks for watching, and I will see you in the next one.
I want to die before robots happening, okay? Robots are coming, yeah, they are. Anyways, really cool video and interesting. I don't think it is time yet, guys. This will be Call of Duty in the future, by the way, but I don't see games like Witcher 3, Stardew Valley, Animal Well, like those games that have very high and deep gameplay. I don't see them happening through this in the future. Because the key component that is missing still is not that, but essentially innovation, making something new.